Hello viewers, today we will be cleaning and repairing a Duracraft 12-inch oscillating fan. The model I believe is still unknown. I don't see it on here anywhere. There's the date code. I believe that means it's from 1996. And it's absolutely filthy on the inside, but it looks almost new on the outside. That's kind of curious. I guess somebody must have cleaned this at some point, and although they weren't thorough enough, they output a lot more effort than most people seem to do. So we need to repair this because it doesn't run. I believe the bearings are probably just locked up, or actually it might have been the oscillator that was locked up. Something about it wasn't quite right. Power bar isn't plugged in. I'm thinking about it more now, and I think it was the oscillator that was having the problem. Yeah, okay. Although the bearings themselves are clearly not the greatest either. They're definitely quite stiff. So, this is going to be a little more challenging than a standard oscillator because we have a lot of things in the back here that we wouldn't normally have. This mechanism here is more complicated than usual because the switch is residing in there. So it's going to take some time to get that off and apart and figure out how it works so that it can go back together. The other irritation with this is these clips. These clips are very difficult to get off, and you have to be very careful because they're getting brittle with age and time. And so you put too much force on one of them and it's going to snap irreparably. And we certainly want to avoid that. So I'll do the best I can to not break any of these. It's not really a great way that I know of to get them off other than to kind of very carefully push them with the screwdriver. These are kind of unusual. They're not like the ones that came on the Galaxy Lasco fans from years ago. These appear to stay on the guard, so that's fine. Those will just stay on there. I'll go through here and get the rest of these off now. Okay, those are removed. Wasn't quite as bad as I thought it was going to be. So we'll set that aside for cleaning. Take the blade off. Oh, it's all rusted. Okay, so we're going to take note of that, and we're going to put some oil in there when we reassemble. This is probably going to be stuck on there as a result. Oh, actually, that wasn't too bad. Some rust in there, and we've got to clean that out. Can see where it was dirty and somebody cleaned it out. Actually, they did a pretty decent job. A lot better than we usually see. But they did not get in the motor. That's probably why it started running kind of hotter than usual, and ultimately that caused the lubrication to dry up prematurely. So I think I'd pay more attention to where this camera is pointing. Alright, so we'll get that off. And once we get in here, we've got 2 screws to come off to remove this front cover. Okay, and you can see it's a pretty nice motor that's in here, but it's very dusty. This is quite dusty. A lot of dust in there, actually. I thought this didn't have a lot of hours on it, but I was mistaken. It does. Got a lot of hours on it. Now we have a C-clip here on the shaft. We're going to have to get that off. Try to just pull it off with the pliers. That may not work. No, it's not going to work. What I need is like a vice grip kind of thing. Of course, I don't have that on hand. Let me try with this set of pliers instead. There we go. These have a little bit more of a tread to them, if you will, so that we were able to get it off. Okay, we'll set that aside. We're going to have to sand this down really good because that's all very, very rusted. Okay, now on the back we have another screw keeping the motor housing on. And then we have the oscillation control. Is that not going to come into there? There it goes. We have this, which I believe is supposed to just pull off. I always hate doing this because it seems like it's going to break. But I think, there we go. That wasn't too bad. Okay, so we'll get this motor housing off. And then we reveal this. It's a good thumbnail. That is filthy. Okay, so at this point we're going to get the vacuum out and kind of brush some of this dust off into the vacuum so that we don't make a total disaster out of the studio. Now what I want to do is get the motor to a state where we can operate it so that the shaft can be cleaned. Now it looks like this this is not designed very well because the screws to take the oscillating mechanism off are hidden behind this capacitor, and the capacitor's screws are not that easily accessible either. Actually, there's only one. I thought there was two. That's not quite as bad. Probably can get in there with a narrow driver. Okay, capacitor is detached. Now we can remove the oscillator mechanism. Okay, now we're going to take some detergent oil and we're going to put it into the front and back of the shaft. And this will kind of clean out the bearings and make it run enough that we can sand down the front for removal. Okay, so now that's in there. It's still pretty stiff because the dried up lubricant that's in there, but that's fine. It'll be good enough to run for now. So I'll plug this in. It's operating, and I'll get the sandpaper out. I'm going to use the very coarse sandpaper in this situation because there's a lot of rust that has to come off of her. Now that the shaft is clean, we'll be able to separate the motor and pull the bearing off of the shaft. So let's do that now. 4 screws on the back of the motor that we're going to remove. Okay, with those screws removed, this should split apart. It looks like it's the front that's going to stay attached, and then the stator is going to be inclined to stay with the rear because the cord goes through it. So this is not going to be easy to get the shaft out because it's going to have to pull through the back. And it won't do that because the windings will prevent it from going through that way, so it has to go this way. This is going to be very challenging. We may have to go into the stand and release more cord because there's just not going to be enough slack to get it out, because it's got to come back another 2 inches so that the shaft can go through there. Okay, this is going to be very annoying. I had a suspicion that this wasn't going to be easy, and it's not. That's okay. We can do hard things. So, I'm going to put one of these screws back in just to keep this from coming undone and getting the windings scratched up or something. And we're going to proceed into the base. See if we can remove disassemble the stand here. It looks like there may be 2 screws hidden under these things. I can't tell. They don't seem interested in coming out at all. There's things that look like that all over here, so those could not be, those could potentially not be screw holes. They could just be part of the design. In that case, I really have no idea how this comes apart. It's going to take some time to figure this one out because this piece here goes all the way down into the base, and so unless this disconnects to let the whole thing come up, I don't see how you'd get that off. It wasn't as hard as I thought it would be. There's some kind of a latch under here, and that releases the whole mechanism from the base. I had suspicions it would come apart because I think these did not ship assembled. So it was just a matter of solving the puzzle. Okay, so now we'll get back to this. There's one more screw, that's why it wasn't coming apart. And this switch mechanism I do not want to take out. I believe I can pull this out without taking it off. Yeah, this should be able to come out, I think. Yep. Okay, so there's that. This will unscrew. That will come out. This should release from here, I think. No, or perhaps not. Well, we've gotten as far as I needed to go because now I can slide this wire up there. But I'd like to see if this will come off. Yes, it will. Okay. Now that didn't do me a whole lot of good because the wires are still attached, but that's fine. Now I can slide this up like this, which means the motor can slide back, and we'll be able to get this motor apart. Jeez, we're going to need all the slack we can get here. Okay, so that's that. Now I can take the stator off the back and should be able to pull this out enough that we can do this and then pull this out the back, because for whatever reason they made it such that it can't go through the front, which is kind of illogical, but then again they never intended for it to be serviced down to this extreme. So alright, so now we're inside here. A couple of these wires are coming loose. I don't like that. This tie wrap just broke. That's pretty typical. This is exposed to a lot of heat and it just becomes brittle over time. This tie wrap, so that's fine. We don't really need that. I can put another one in if I want to. And now we're into the motor, so we can service the motor. Let's set that down there like that. And this thing, I'd like to clean this off because it is quite dirty. I don't want this to get screwed up. What I can do for this is I can just pull the wires out of the switch and then that will release this. I think we're going to do that. So I'll take, first I'll make a diagram. Okay, the diagram is made. Now I'm going to take a paper clip and stick that in there, and then this should pull out pretty easily. And then of course this will get stuck naturally because that one and this one too. Are you serious? Both of these papers clips have like kind of a texture to this, to the surface of it, and that's not useful in this case. All the stinky paper clips. Okay, we'll use a tack. Because this is a flat surface with no whatever that you want to call that on there is. Hey, that's not working. We use this pointing thing. Actually, I probably could just use the pointing thing for them all. Nope. I need to just get a different paper clip, that's all. I don't happen to have any on hand, but I'll get one. Okay, so now that that's removed, and we got paper clips everywhere and tacks, unnecessary tools. This project, this is to the point where we can almost remove wires. We have one of these left, and these are hit or miss. Sometimes you can undo them and reuse them, sometimes you can't. Let's see what will happen in this situation. In this case, we'll be able to remove and reuse it. Alright, now we're ready to do some cleaning. Plastic parts have all been cleaned. Now we have to deal with the motor, which is going to take some effort due to the amount of filth that's in there and the way it's not fully coming apart like I'd like it to. So this actually we can set aside for now. Now let's begin with the front bearing. Now this wasn't oscillating very well, and while this is turning freely at the moment, if you put any pressure on here, it starts to squeak. So this is only a plastic bearing, so we may never be able to get it quite right, but we'll try to put some oil into there. Now there's a lot of dust in here still, so I'm going to try to get this dust out. Okay, I think that's pretty good. It doesn't have to be perfect. It's not a cosmetic issue. And now we're going to clean out the bearings. We'll start with the front bearing and move on to the back bearing. Okay, the bearing is pretty clean now. See if I can wipe away the rest of the junk from inside there so it doesn't get on the shaft as we slide it into place. Okay, that's pretty good. Now, this, I'll do the same thing, we'll wipe the dust off here. There's a lot of dust in there. And now as far as the bearings go, or the bushings rather, thrust washers, we have quite a few here. There's actually 3. This black one is independent of this white thing. It's not wanting to come off, so we're just going to do this, and we're going to slide everything off. And this needs to come apart like that, so that this can be cleaned, because this plastic piece should be able to spin freely on the shaft if it's working properly, and it's not going to be able to do that, this amount of dirt that's on here. So we're going to clean all this off. The dog is going to provide some unwanted dog commentary. Clean off the inside of this as well. And this is the same color as the dried up lubricant, so it's kind of hard to tell when that's clean or not. This one looks like it's starting to get some wear on it. These are only plastic, so they don't last forever. I don't really know where to get new ones. There's got to be somewhere that makes these things. It's just a piece of plastic. Probably could make one out of something. Because usually when like the C-frame motors get kind of noisy, it's because these worn out. These motors don't seem to have that issue as much. I don't think this will have a problem running with these washers as they are. Okay, so that's pretty clean now. I'll clean the shaft off as well, because it's kind of sticky. And if you had a lathe, you could put this in the lathe and take a very thin layer off of here to get rid of that scoring on there. It's not really even deep enough to feel it, it's just kind of a cosmetic issue. And so if we clean it off, you know, with this cloth, that'll be good enough. But if you really wanted to make it look better, you could take a, you know, very, very fine sandpaper, maybe even steel wool to this, and clean that off. But that's good enough for now. So I'm going to go ahead and do the same thing to the other side. I have to get another ticker towel. Okay, so I'll put this, oh, we're going to hold off on putting that back on because it should be, well, no, actually I guess we can put it back on now. Electric motor oil, I will do that segment after I, you know, when I go to reassemble it. I'm going to put just a little bit of oil on there for now. And this will go back on. And it's not going to, you know, coast on there, but it spins freely. And then these two. The white one should really coast. Black one will stay in place to an extent. Okay, so now we'll do that on the front. Moving on, we're going to get to the front bearing now. Or it may be better to clean the stator first so we don't fling dust into the cleaned bearing. You have to be very careful when you clean these stators off because these wires, especially on this one, are pretty thin and fragile. And this does not have to get spotless, just enough so that the air will flow through as it was intended to originally. I'm noticing something I don't like about this stator. There's several places, in particular right here, where the wires are just kind of freely there. Here's another case right here. This wire is just freely kind of dwelling there. And the problem with that, and here we go, actually this is the worst case right here. See this wire, I don't know if this will pick up on the video or not, but this wire right here, come on, unblur. This is important. Okay, this wire here, it moves. It's not bound to the rest of these wires. This is very terrible when it's like this, because what happens is there's a magnetic field here that's fluctuating, and so these wires can vibrate as the motor is running, and over a period of time, if these wires are vibrating against each other, the varnish can wear off, and that's ultimately what causes the motor to fail. When that varnish wears off and you get an arc between, or any kind of continuity between these wires, you'll get a motor burnout. And so really this should be revarnished so that these wires are not able to move and they're kind of held in place. I'm not going to do that today, but I'm going to make a mental note of this, and at some point down the road I will revarnish this stator. Alright, moving on to the rear bearing. There's quite a bit of dust in here once again, so we'll get that dust out. Oops. Now that just came off of there. Okay, now this is going to be... Okay, this is going to take some time now to fix that. That's fine, I can fix that, but I just didn't want to have to do that. Geez, I wasn't even being that aggressive either. It just goes to show how brittle the plastic tie wraps get when they're exposed to the heat of the motor. Of course, paired with the motor not cooling correctly because of too much dust. Alright, well, let's stop here and let's fix this, because right now this is easily repairable. If this breaks any further, then now we're getting into very advanced repair, and it's going to take some time. So I got to find a tie wrap here and then we'll proceed. While I was looking for the tie wrap, I found this. This is a piece of metal that's the handle from the Chinese takeout food containers, and this is the perfect thing to use to get the wires out of the switch, because it's a straight, smooth surface. So I'm going to replace those paper clips with that. Anyways, here's the tie wrap, and what we need to do here is we need to position this. This is actually under quite a bit of pressure, being like that. But that's how it was. We're going to put this back like this, and tie wrap, all it needs to do is kind of hold this in place. I'm going to put it, I like to get these loose wires under there if possible. Of course, also paying attention to not flex them enough that the varnish breaks down. And then we're just going to secure this connection down to the windings. And it needs to be kind of tight, because you don't want anything vibrating. Okay, that'll be sufficient, I think. Alright, that was unexpected to have to do that, but that wasn't a big deal. In a lot of ways that was probably an issue prevented, because at some point that tie wrap would have broken anyways. Now it's not a problem. Okay, so let's proceed with the lubrication. of this rear bearing and the cleaning, of course. And just for demonstrative purposes, here's the old tie wrap. There's two of them on there, and you can see how the plastic has yellowed and become brittle because of the heat exposure. So here's the rear bearing. I wish this would detach from the windings. If I had another tie wrap, I'd just delete this one and redo it, but anyways, let's clean the bearing out. Okay, that's pretty good. And I'm going to make sure that the surface on the back here is all cleaned out as well, because that does make contact with the thrust washers, so you want to make sure that's lubricated properly and not sticky or dirty at all. Okay. Now we're going to lubricate the bearings. Two kinds of oils we can use. Of course, the infamous blue in one, 3-in-1 blue can, which is for fans. And we could also use the Zoom spout, which is specifically for electric motors. I'm going to use this for the moment, and I'm going to fill this up with oil. There is a sponge-like material in there which will absorb the oil, and it will feed into the bearing over the years as it's needed. It'll take a fair bit in, especially because it's probably been over 20 years since this was oiled. Okay, and let that sit for a while and seep into the bearing. We can take these away now. Don't need that. And then we're going to do the same thing with the front bearing. Fill this up with the oil. Okay, I'm going to let that sit for a few minutes. Let the gravity pull that into the wick, and then we will reassemble. Oil has seeped in. Now let's see if we can get some oil down here. And this may or may not work. I'm not really sure if this will do any good. I don't think this comes apart. No, it doesn't. Ideally, some kind of a grease probably would be better. This piece of plastic is deteriorating. You can see how yellow it is. The integrity is just not there anymore. And that could be part of the problem. I don't want to put too much in here because then it may leak. And that would be pretty bad. You know, it could leak out through the base, onto the table or whatever, and that's not good. Still kind of squeaks, but I'm going to leave it at that. I very seldom actually use the oscillation feature anyways, so I'm not concerned about it. It is what it is. Okay, so let's begin to reassemble the motor. This is going to be kind of difficult because the way I have to cram this in here. Let's see, this is going to go through the front, but it has to go through here first. So I'll put this in here, and then it has to go through here like this. I don't like the way that sits at all. Wire is just kind of tight. So I'm going to put a little bit of oil on the shaft here, not a lot. That was more than I wanted. And then I will slide this back here into the bearing. And I want to make sure that these wires don't get too stressed out as we put this back in. I may have to detach the wires from here because this is not the right tension anymore, because it got slightly moved. Actually, maybe it'll be okay. Oh, there we go. It's closed. I think that'll be okay. So that's that. Okay, and now I'm going to put some more oil on the front of the shaft, and we're going to put the oil along the entire length because the whole thing has to slide through the bearing. Okay, so there's the motor reassembled. Okay, now I'm going to put the screws in, and then we'll deal with the alignment, because there will be an alignment issue. These screws should be firm and equally torqued, but not very tight. Now the motor at this point is probably going to be very stiff, and this is an alignment issue. I'm going to take a rubber handle screwdriver and strike the shaft. And that will free it right up. Now we'll put some additional oil down the shaft. On the front, and we'll do the same thing in the back. And that will conclude the cleaning and lubrication of the bearings. Now we're going to put this back together so that we can test the motor and make sure everything's okay in there. Okay, it goes like that. And wires have to... Is this leaking oil? is a little bit too much oil on one something in there. Okay, so the wires have to go through here like this. Get all these together and feed these through. Is that right? No, it's not right. What's the problem here? Okay, what am I doing wrong? That is correct. Oh, I see what the problem is. This is supposed to be pushed down further. Oh no, something's totally wrong here. This is totally jacked because the oscillation mechanism, those screws should be about over there. Okay, we gotta take the motor back apart because I goofed the reassembly of the motor. Now that's correct. So now the oscillating mechanism can screw onto here like it's supposed to. And this wire will be able to have enough slack to feed down into here like it's supposed to. And everything will be just fine once again. Let's try that again. Wrong. Oh dear. It's time to stop and have dinner, I think. Nope, it was right the first time. Here we go, that's how it's supposed to be. Now this is my diagram here, so we don't get confused. Why in the world did I do it like that? Well, if this is wrong, I can fix that easily enough. I wrote the diagram in kind of a weird way. I don't know why it did that for. Okay, so that's the switch. And these not even wrapped together. They were just kind of sitting there inside that thing. I'm going to wrap them together because I think that's how it should be. Okay, now let's give this a test. So this should be low, I think. Low. Okay, I think that's correct. Okay, I think we're past the worst now. So let's continue with the reassembly. Something's not right about the way this is. I think I put that piece in backwards. Jeez, I'm making a lot of mistakes this time. Yeah, I think I should go the other way. No, I can't go the other way because then you wouldn't be able to screw it in at all. I guess that's just how it is. It doesn't seem quite right, but there's no other way for it to go. I just found the informations. They're pretty much impossible to read. Well, they are impossible to see with it assembled, but here they are. Model DT-12, made in China. Don't see a date code on there. But there it is. Now we know it's a DT-12. Probably already knew that because someone told me and I forgot, but now we know it again. In an attempt to cut down on this rust, I'm going to put a very small amount of oil on here. Okay, that was a lot of oil. It's enough to cover the threads. That's more than enough to cover the threads, but whatever. And then we'll slide this on. Bearings seem kind of stiff. I almost wonder if the shaft is bent. There's like a point where it grabs. So here it's free. Very free. And then it grabs there. I don't think it'll really be an issue as it runs, but it's going to annoy me forever. Just because it's not quite right and it should be. But let's power it on and see what happens. This is high. It seems to be running just fine. It's a little out of balance. It's oscillating with no complaints. It seems to be oscillating just fine. There's a stinking fly in here. And the spin down is not really what it should be. And it's not. See, it's free, and now it's locked up. So there's something. You know what it could be? Is it could be something, some kind of dirt or something accumulated on the worm gear, only at a certain point, and that's why. Because it definitely is. It's only one point along the rotation that it does it, and then it's fine. So. I'm going to run it for a while and see what happens. Maybe it'll work itself out. I don't want to be taking this guard on and off with any regularity because of the way these clips are. I really don't like them, and I think they're going to break any soon. In fact, I may, if this proves to be a troublesome fan, I may just take them off and replace them with something else. This requires an awful lot of force to get it over the lip there, and it's just a matter of time before the plastic will shatter. And I don't think there's going to be any finding replacements for these. I can't even get this one to go on. Well, maybe it's going to get replaced sooner than later because this is not workable. Here we go. I'm just going to do those two for now, and I'll let it run for a while, and then we'll check back on the video and see if anything has changed. There's something wrong with the oscillator. It's almost stalling out on low. I think if I stopped it, it probably would. Yeah, it's almost fixing to stall out, and it certainly should not be like that. So there's something wrong. It could be that plastic bearing, or it could be something in the gearbox. I didn't look in the gearbox because there's nothing I really do in there. I tend to think it's probably the plastic bearing. I never really use oscillation mode anyways, so I'm not going to spend any more time on it today. This will have to get revisited at some point. But I do want to keep running it for a little while to see if the tightness in the bearings goes away. Because there's definitely something not right about this, and I definitely think it's sourcing from the oscillator box. It's been running for about an hour. Let's cut it off and see what happens. That's a little better. Could also just be because the bearings are warm. Either way, I think it's good enough to use it now, but this will definitely have to be revisited at some point.